Dear students, Chapter 5, Maths 2, Coordinate Geometry. Chapter 5, Maths 2, Coordinate Geometry. Coordinate Geometry. Now you have already studied, okay, some part of coordinate geometry in 9th standard. You know that this is the vertical axis in the xy coordinate system called as y-axis, shown as y dash, and this is the horizontal axis in the xy coordinate system, okay, denoted as x dash, and it is called as the x-axis. The point of intersection of both the axes, is called as origin, shown as O, O means 0, 0. These are the positive integers 1, 2, 3 here. Okay, positive direction of x-axis. This is negative direction of x-axis. Negative integers -1, -2, -3, -4. All are there. Okay, then here these are positive integers on y-axis. Positive direction of y-axis 1, 2, 3. All these positive integers we have to show. And here negative direction of y-axis, negative integers -1, -2, -3, -4, etc. This is called as xy coordinate system, which you already studied in 9th standard. And you know that in this xy coordinate system, okay, we can locate the points. Okay, if suppose there is a point here, okay, then how to show the location of this point A? We can show the location of this point A by the ordered pair. Ordered pair means pair of numbers 2, 2. This is called as ordered pair. Okay, the first number is called as x coordinate and second number is called as y coordinate. Second number is called as y coordinate. Okay, also called as abscissa and ordinate. Abscissa and ordinate, which we have studied in 9th standard. Okay, now thus location of any point is shown by the ordered pair. This is called as ordered pair. Ordered pair, okay, which is used to show the location of any point. Now student, in this chapter, in the beginning, we have to study about what? Distance formula. We are first studying, okay, in 10th standard coordinate geometry chapter, the formula which is called as distance formula. And what is the meaning of distance formula? This formula, as the name suggests, gives us the distance between any 2 points. For example, there is a point A here which we have already taken 2, 2, and there is another point, say y here. Okay, I am taking in this is the first quadrant, as you already know, first quadrant, and this is the second quadrant, this is the third quadrant, this is the fourth quadrant, like that, quadrants. Now if suppose I have taken point A 2, 2 in the first quadrant and point B -2, -2 in the third quadrant, and I want to find the distance between the 2 points A and B, then I have to use the distance formula. Now what is the distance formula? Okay, for any 2 points, as we have taken here, say A, let us generalize it x1, y1, this location, the location of the point is shown by ordered pair, and here I have written the ordered pair as x1, y1, and B, x2, y2. For any 2 points A and B, the distance AB is equal to the distance AB, okay, is given by the distance formula, okay, which is as follows. Okay, what is the distance formula? Distance AB. See how we write distance AB, which you have studied in 9th standard. D, we use a pair of brackets, A, B we have to write. And how to read this? Distance between the points A and B is under square root. Okay, under square root, what we have to write? x2 minus x1 the whole square plus y2 minus y1 the whole square. We can also write this as distance AB equal to under square root x1 minus x2 the whole square plus y1 minus y2 the whole square. Doesn't make any difference. Okay, meaning is same. So this is the distance formula. Now if suppose in the given example where a has coordinates 2 comma 2 and b has coordinates minus 2 comma minus 2, okay, if you have to find the distance, then how will you find? So for the above, for above example, distance AB, distance A comma B is equal to, what is the formula? Under square root x2 minus x1 the whole square plus y2 minus y1 the whole squared. So this is equal to, x1 y1. So let us give this number as x1 and this number yani abscissa as x1 and ordinate as y1, and let us name this as this abscissa as x2 and this ordinate as y2. Now it is x2 minus x1, so minus 2 minus 2. So as you can see here, minus 2 the whole square plus y2 is this minus 2 and this y1 is 2. So y2 minus y1, so minus 2 the whole square. So you can see here that minus 2 is minus 4 the whole squared, and again here I have to write minus 4 the whole squared, and so finally I will get negative square of negative number is positive 16 plus 16 and it is root 32, which can be split into mixed surd. Okay, converted into mixed surd as 16 to the 32, so it is 4 root 2 units. So finally we can write that therefore distance A comma B is equal to 4 root 2 units. This is how we have to solve the sums, okay, to find distance between any 2 points. So this is the first formula of the chapter. Coordinate geometry chapter is very simple, okay, but you need to understand. Now you take 2 points A and B anywhere. The 2 points can be on x-axis, the 2 points can be on y-axis, or 1 point can be on x-axis, other point on y-axis, or the 2 points can be in any coordinates anywhere. You can do the thing we must know about the 2 points means are we must know the coordinates, we must know the ordered pair of the 2 points, and so we will be able to find the distance between the 2 points. Okay, this is the introduction for practice set 5.1. okay, now in practice set 5.1 there is a first question. Okay, practice set 5.1, the first question says, question number 1, find distance between each of the following pairs of the points. I am simply writing find the distance between given pair of points, given pairs of points. Okay, there are few questions given here. We have to use the distance formula. The first question is, the points are A having coordinates 2, 3, the ordered pair is 2, 3, B has ordered pair 4, 1. Both these points are the points of the first quadrant. So in the answer we write A 2, 3, okay, is equal to x1, y1, and B has ordered pair 4, 1, which means these are x2, y2. Okay, therefore by distance formula we must write this. Therefore by distance formula, okay, distance AB, distance A comma B is equal to under square root, I told you we write x2 minus x1 the whole square plus y2 minus y1 the whole squared. Okay, or it can be x1 minus x2 the whole square plus y1 minus y2 the whole square. Now as you know, x2 and x1 value, x2 is 4 and x1 is 2. So 4 minus 2. So under square root we write 4 minus 2 the whole squared plus y2 is 1 and y1 is 3. So 1 minus 3 the whole squared. Okay, so we find 4 minus 2 is 2 squared and 1 minus 3 is minus 2 squared, which is further simplified as 4 plus 4. Negative number, square of negative number is positive, root 8. We can convert this into mixed surd. We can split 8 as 4 to 8, so it is 2 root 2 units. So this is how, like, and finally you always write as a habit or make it a habit to write this way the answer 2 root 2 units. So this is the use of distance formula. Okay, now question number 1 has totally 6 questions, 6 sub questions. I am not solving all. Okay, I will like solve those which are little bit difficult. So I am now solving the third one in the question number first. We have the points R having ordered pair 0, -3, and we have another point S having ordered pair 0 and 5 upon 2. Okay, so as usual we write R has ordered pair 0 -3, which is x1 comma y1, and we have S having ordered pair 0 comma 5 by 2, which is nothing but x2 comma y2. Now therefore we write by distance formula what we have to write, distance RS, the 2 points under consideration are RS. Distance RS is equal to under square root x2 minus x1 the whole square plus y2 minus y1 the whole square. Okay, so now we know under square root x2 is 0 and x1 is 0, so 0 minus 0 the whole square, and y2 is 5 by 2 minus y1 is -3, so minus 3. I will have to make double bracket and then the whole squared. Be very careful now. So 0 minus 0 is 0 square, which is 0. We need not write it. And here inside the bracket 5 by 2 plus 3 the whole square. Now how to solve 5 by 2 plus 3? I am solving separately. Take upon 1, 3 upon 1, and we have to do cross multiplication this way. So it is 5 ones are 5 plus 3 twos are 6 upon 2 ones are 2. So it is 11 by 2. Finally it will be 11 upon 2. So we write here that under square root 11 upon 2 the whole square. Now 11 upon 2 the whole square, and its square root. So it is finally 11 upon 2, or it is also equal to 5.5 units. Remember, your answer would always be positive because distance between 2 points is always a positive number. It is a non-negative number. So finally we write therefore distance RS is equal to 5.5 units, or we can also write 11 upon 2 units. Okay, this answer you have to make a box around it. So this is how we can solve the sums. Okay, this is the distance formula. Now the remaining sums, I hope you will be able to do. I will still solve one more sum, and so the first sum, remaining sums in the first question will be your homework. Okay, I will do the sixth one. Okay, I will do the sixth one. I am just shifting the page. Sixth sum I am writing here. The 2 points under consideration are W having ordered pair -7 upon 2, comma 4, and another point is x having the ordered pair 11, comma 4. Now, okay, I think it is proper. Okay, now as usual we write point W having ordered pair -7 by 2, comma 4, which can be taken as x1, comma y1, and the point X has ordered pair 11, comma 4, which is taken as x2, comma y2. Okay, therefore by distance formula, which distance we have to find? Distance between the points x, w and x, या तो x and w, wx या तो xw is equal to under square root. We now use x1 minus x2 the whole square. It is same as the previous one. There will not be any difference in the answer. Plus y1 minus y2 the whole square. Okay. So as you see, x1 minus x2, this is x1 now. x1 is -7 by 2 and x2 is 11. So -7 upon 2 minus 11 upon 1 the whole square plus y2 minus y1. y1 is y1 is 4 and y2 is also 4. 4 minus 4. 4 minus 4 the whole square. So which can be written as minus 7 okay upon 2 minus 11 upon 1 the whole square only, because 4 minus 4 will be 0 square, which will be 0. Now how will you solve minus 7 by 2 minus 11 by 1? So as we have done here, cross multiply. Minus 7 into 1 is minus 7. Minus 11 into 2 is minus 22 upon 2 ones are 2. So it will be minus 29 upon 2. Okay, minus 29 upon 2. So we write which is equal to minus 29 upon 2 the whole square. Now square of a negative number is positive, and square root of any square is that number itself. So it will be 29 by 2. What is our answer? 29 upon 2 units. Okay, so finally we write, therefore distance xw, so wx is equal to 29 by 2, or which can also be written as 14.5 units. Okay, this is how we can use the distance formula and solve the sums. So question 1 involves the use of like distance formula, direct use of distance formula to find distance between 2 points. Now as we move on question number 2, you will know that how this distance formula can be used to see solve other type of sums. Question 2 says that determine whether the points are collinear. Be very careful. Determine whether the points are collinear or not. Collinear or not. Now, what this has to do with the distance formula? This to determine whether the points are collinear or not. Okay. Now, how the distance formula will be useful in solving this type of sums? So now see, I am like writing the 3 points they have given in the first question. One point is point A having coordinate 1 comma minus 3. Other point is B having coordinate or ordered pair 2 comma minus 5. Third point is C having coordinate minus 4 7. So now what I will be doing here is 1 minute. I think so in the previous sum where I have obtained minus 29 by 2 the whole square, that I will have to see. No, there is no issue. Let us solve this sum first, and if there will be any query, we will solve it. Yeah. Now how will you determine that whether these 3 points A, B and C are collinear or not? Collinear means do they lie on the same line or not? We will use distance formula to solve this. Okay, in the answer what we write? We write point A having coordinate 1 comma minus 3, and we will write this as ordered pair x1 y1. Okay, we have point B, okay, having ordered pair 2 minus 5, okay, which is equivalent to x2 comma y2, and we have third point C having ordered pair minus 4 and 7, which is equivalent to x3 y3. Okay, now by distance formula, okay, first we will find distance AB. So we will have to consider only first 2 points. The formula will be x2 minus x1 the whole square plus y2 minus y1 the whole square. Okay, so which is equal to, we can write this way also. Okay, now x2 minus x1, so 2 minus 1, 2 minus 1 the whole square plus y2 minus y1, so minus 5 minus minus 3, minus 5 minus minus 3 the whole square. Very carefully do this. So under square root I have 2 minus 1 is 1 square plus minus 5 plus 3, minus 5 plus 3 will be minus 2 the whole square. So this is equal to 1 plus 4, which is equal to root 5 units, and we will give this as result number 1. Similarly, we have to find similarly distance BC we will find now. Okay, 3 distances we'll have to find. Now we have to consider these 2 points BC. So we write x3 minus x2 the whole square plus y3 minus y2 the whole square. x3 minus x2 the whole square plus y3 minus y2 the whole square. Take this line up to the end of the formula, which is equal to, now x3 minus x2, so minus 4 minus 2, minus 4 minus 2 the whole square plus y3 minus y2, 7 minus minus 5, 7 minus minus 5 the whole square, two brackets I have to make, which is equal to, right, minus 4 minus 2 is minus 6 the whole square plus 7 plus 5, that is 12 the whole square. So under square root we have 36 plus 144. 36 plus 144 is 6 plus 4 is 10. 1 carried, 5 plus 3 is 8, and I have tried 1 as it is. So 180, and square root of 180 is, again we can split this as 36 5s. 36 5s means 6 root 5 units, which is equal to result number 2. Okay, and now third distance which is left is distance AC. So distance AB we got root 5 units, distance BC we got 6 root 5 units. Now which is the third distance left? First and third point, distance AC, A and C. So I will write, and distance AC is equal to under square root, what I will write, x3 minus x1, x3 minus x1 the whole square plus y3 minus y1 the whole square, which is equal to under square root, okay, minus 4 minus 1, minus 4 minus 1 the whole square plus 7 minus minus 3, 7 minus minus 3 the whole square. Okay, so which is finally equal to minus 4 minus 1 is minus 5 squared plus 7 plus 3, that is 10 squared. Square of a negative number is positive, so 25 plus 100, and that is 125, which we can further split as 25 5s. So convert it into mixed 5 root 5 units. This is the third result, our third result. Now how these three distances will help us, okay, finding whether the points are collinear or not. So we know in the 9th standard we had studied that suppose if the 3 points are collinear, say, okay, which is the biggest distance? This is the biggest distance, and that is the distance between the points B and C. So let us take the biggest distance BC. Okay, BC as 6 root 5 units. Understand? Is it 6 root 5? Yes. So it is 6 root 5 units BC. And now distance AB is root 5 units. AB the points, distance between the points A and B. So B is already there. So let us say A is here. This distance is root 5 units. Okay. So what this distance AC must be? Distance is it 5 root 5? Yes, this is 5 root 5. Is 5 root 5? Is 5 root 5 plus root 5 give means the sum does the sum give you 6 root 5 unit distance? Yes. So what we have to write? This is, okay, you have to understand by yourself. Okay, this is not to be like written in the answer. This is for yourself, for understanding. So what we have to write? Therefore, from, okay, 1, result 1, 2 and 3 we get, that sum of this distance AB, right, distance AB plus another distance AC, distance AC is equal to distance, third distance, the biggest distance BC, which is 6 root 5 unit. So sum of these two distances AB and AC is the biggest distance BC. Okay, this we get from 1, 2 and 3. Now if this is the case, then we can say that this is the biggest distance B and C. So B dash, which point must be in between? A must be in between. B dash, A dash, C. Okay, because we got this because of this result, and we got this result because of these three results which we got here, 1, 2 and 3. Understand? And B dash, A dash, C. Therefore what we can say? Therefore points, okay, A, B and C, A, B and C are collinear points. Thus the distance formula also helps us to find out whether the points are collinear or not. Okay, B dash, A dash, C means A lies between B and C according to this situation, and this we got from result 1, 2 and 3 which we have solved here. This means that all these 3 points lie on the same line, and so that these points are collinear. Points A, B, and C are collinear. So simple sum. This type of sums you have to solve. Okay, in the question number 2. So this is the second question. The 3 points are L, M, N. L has ordered pair minus 2, 3. M has ordered pair 1, minus 3, and N has 5, 4. Okay, this is x1, this is y1, this is x2, this is y2, this is x3, this is y3, like that. Okay, now by distance formula, first which distance we will find between first 2 points? Distance LM equal to, what is the distance formula? x2 minus x1 the whole square plus y2 minus y1 the whole square. Okay, which is equal to x2 you know is 1 and x1 is minus 2. So 1 minus 2 the whole square plus y2 is minus 3 and y1 is 3. So minus 3 the whole square. Be careful about the sign. So under square root we have 1 minus into minus plus 2. 1 plus 2, that is 3 the square, and minus 2 minus 3 is minus 6 the whole squared. So under square root we have 9 plus 36. 36 plus 9 is root 45. We can split this root 45 also into mixed fractions, mixed surd. Okay, how will you do it? 9 5s are 45, you know. So it is 9 5s are 45, which is 3 root 5 units. So we got the first distance LM, result number 1. Now another distance, which is the other distance. Now similarly we write, similarly distance MN, okay, is under square root. MN is, these are the 2 points now. x3 minus x2 the whole square, x3 minus x2 the whole square plus y3 minus y2 the whole square. So which is equal to under square root. x3 is, you see that it is 5 and x2 is 1. So 5 minus 1 the whole squared plus 4 minus 3. 4 minus 3 the whole squared. So what is this? 4 squared, that is 16. I am directly writing now. And 4 plus 3 it is. So 7. 7 squared is 49. 49 plus 16. 9 plus 6 is 15. 1 carried. 4 plus 1 5 and 1 6. 65. Can we split 65? No. Okay, 13 5 is 65, but 13 and 5 both are prime numbers. So we cannot convert this into mixed surd. Final distance we have to find is Ln, and distance Ln is equal to under square root x3 minus x1 the whole square plus y3 minus y1 the whole square, which is equal to under square root x3 is 5 minus 2, 5 minus 2 the whole square plus 4 minus 3 the whole square. So what we have here is 5 plus 2, that is 7 squared, plus 4 minus 3, that is 1 squared. So which is 49 plus 1 squared is 1, which is root 50, which we can further split as 25 2s are, which is equal to 5 root 2 units, and this is result number 3. Now which is the biggest distance? We can't say. Okay, can we add any two distance and get the third distance? We cannot. Okay, we know that distance, this distance 5 root 2 units and 3 root 5 units. 5 root 2 and 3 root 5 we cannot add because they are different numbers. Okay, so we don't see any relation. We cannot add. Means if you add, like what we have to write, therefore from 1 2 and 3, what we can write is, okay, we get that sum of any two distance, the distance LM plus distance MN is not equal to distance LN. Okay, or second and third is not equal to first. Distance MN plus distance LN is not equal to the first distance, that is distance LM. Okay, or the first and second is not equal to third, second and third is not, sum of second and third is not equal to first, so sum of first and third is also not equal to second. Okay, distance LM plus distance LN is also not equal to distance MN. So here you should get all the distances once. Okay, therefore points L, M and N, points L, comma M and N are not collinear, are not collinear. This is how we can prove whether the points are collinear or not using the distance formula. So rest of the sum in question 2 you will have to do by yourself. Okay, I will move to do the third sum now. There is a third question I will write now. So now this is the third question. Okay, rest of the sub questions of question 2 you'll have to solve by yourself. I did 2 sums and you have to solve remaining sums. Now question 3 I have already written. Find the point on the x-axis which is equidistant, okay, from a minus 3 4 and b 1 minus 4. These are the given points. We know that x and y coordinate system is this. Okay, this is the standing axis y axis, this is the vertical axis x axis. Now as you know, a minus 3 4, minus 3 4 is the point of which quadrant? It is the point of which quadrant? Fourth quadrant. Minus 3 4, sorry, it is the point of second quadrant, and 1 minus 4 is the point of fourth quadrant. So approximately a where it could be? Minus 3 4, so here 1 2 and 3 is there. Okay, and 4 1 2 3 4, so approximately it is the point here, a minus 3 comma 4, and b is 1 comma minus 4, so here 1 2 3 negative positive, and these are negative, and minus 1 minus 2 minus 3 minus 4, so 1 comma minus 4, it is a point here b having coordinates 1 comma minus 4. Now there is a point. Now the question, see the question, find the point on the x-axis which is equidistant from a minus 3 4 and b 1 minus 4. So on x-axis there is a point, there is a point on x-axis, okay, which is equidistant from a and b. Say that point is, say, point C, like that. Okay, we can take point C, any point C. Okay, I don't know the coordinates, I have just approximately taken point C, and let us take the coordinate of point C as x3 y3. Okay, now it is said that this distance AC and this distance BC are same. Understand? So these are equal distances. So what are the coordinates of point C? So find the point on the x-axis. This is the x-axis. I have taken a point C. It can be here, it can be here, it can be here, it can be here. Throughout x-axis it can be anywhere. I have taken, supposedly it is at this place C. Now it is such a point that it is equidistant from A and B. Okay, so what you have to write? In the answer we write that let point C, let point C having coordinate x3 comma y3 be equidistant from okay, a minus 3 comma 4